Dip and strike problems are the very important problems, as we use these problems for understanding the underground strata. Okay, so we'll directly start with this part. So dip and strike, before we jump directly into dip and strike, which I already studied, what is dip, what is strike, you answered them, but once again let me explain you the concept of what is dip and okay, so we'll be seeing today the set number 3 of dip and strike problem, where we need to determine the apparent dip direction. We need to determine the apparent dip direction when true dip direction as well as amount and apparent dip amount is given. So here the three things are being given, and among that we need to identify only one parameter. Okay, so these problems, let's see the first problem. A sedimentary strata has a true dip of 1:6.5, due north 20 degrees west. So they have given a true dip here, and in what direction will be the apparent dip when the apparent dip amount is 1:13. So they have given apparent dip amount also. So we need to identify the apparent dip direction only. So we'll see this in a next slide. We'll start with the first problem. Okay, so here what has happened, problem number 1, 3.1 from dip and strike. Okay, so dip and strike problems will be solving here. Okay, so then a sedimentary strata has a true dip of 1:6.5 north 20 degrees west. We'll be writing down this in a given data. So they are given a true dip direction, that is north 20 west, and they are given true dip amount is 1:6.5. they already read it in the problem, and they given apparent dip amount also, that is 1:13. That is 1:13. When they give this data, we need to identify the apparent dip direction. This is a question mark, and also the strike direction. This is again, now they are among the four, they have given three things. We need to identify the one remaining part. Let's see how this one remaining part need to be calculated. So we'll start solving the problem here. Okay, it says that a determination of apparent dip direction when true dip direction amount, also the apparent dip amount is been given. So the given data, I am writing it here once again for your understanding. It will help us in plotting it. So here the first, as usual, we'll be drawing north south east west line. Then we'll name that intersection as O, and north south east west we'll be drawing it. Okay, so then we come to the second part, that is unit. We'll be writing one unit is equal to 2 centimeters. Here why I am writing first unit is we have changed the unit. Earlier we have taken 1 unit is equal to 1 centimeter. It was so simple, but here because of the space constraint it will not fit on your paper, so we are changing the scale as 1 unit is equal to 2 centimeters. So this everything, only the amounts, remember, only the amounts will become half. But directions will remain as it is. You should not divide the directions with the unit. These directions are with respect to amounts only. 1:13 is there and 1:6.5 is there. Okay, so first I'll be plotting whatever is being given. North 20 west, I plotted it here. Then once I plot north 20 west, I'll write down here, this is a true dip, north 20 west, it is written already. And then we'll see the amount also. So this is 1:13. This is 1:6.5. Because true dip will be plotting, this part will be plotting now. So 1:6.5. Again that I divided with 2 because scale is, so this is 3.25 it will be. Okay, but I'll be taking it only 3.2. 3.2 I plotted and named that point as point A. I'll name that point as point A. Okay, and then as this is a true dip, I'll be plotting my strike line, and the relation between strike line and true dip, they are perpendicular to each other. So I plotted a strike line, and apparently this is 90 degree here, exactly 90 degrees we plotted, and apparently it has been shifted at point O also. Now comes the major part. So this true dip amount has been completed. Now we need to think about the remaining part, that is apparent dip amount. What you will do with apparent dip amount? We need to plot that amount. But question is, in which direction is the apparent dip? Either this is on the right hand side of true dip or on the left hand side of the true dip. That is the question. So what we'll do is, we'll take a compass. We'll we'll measure 13 centimeter. Now the unit is there. What is that unit? 1:2. So 13 will be 6.5. So I'll measure 6.5 here. I'll measure 6.5 centimeters here, and I'll keep one edge, sharp edge at this point, and plot the line on both the sides. So intersection point, I named it as point B. I'll name it at point B. Same way on the other side, okay, I'll be plotting it, the intersection point as point C, and intersection point as C. Then I'll join this with O, and how much this will be? This is 1:6.5. It should be. This is a mistake. This is 1:6.5. Same way, this is also 1:6.5. 1:6.5. Now if I measure these angles, and measure this angle, both the angles if I measure, then I'll get the apparent dip directions. Why I'm getting two directions? That is because we don't know in which direction is. So for a safety purpose, we plotted on both the sides of the true dip. Okay, so now we got two directions. These directions will be measuring. Also for our strike direction, we'll be measuring this as well as this. We'll get the strike direction also. The major angle, this will get the strike direction. Okay, so the answer are the OB is north 35 east, OC is north 81 west. You plot it on paper, you will understand this. Again, you go through this video, plot step by step. I'll play the video here once again. You go step by step, you will understand how to do it. Okay, then we have the strike directions. Again, with respect to north, with respect to south, we'll get it. Fine. So this is how the problem look like when you plot it exactly. I done lots of work over there. When you plot it properly, okay, just you need to write down this part. You need to write down this part also, this angles which you are measuring. Mark this. You will see a beautiful diagram like this. Okay, so this is the problem 3.1. Okay, you solve this first, then we'll see 3.2 also. Let's see the problem number 3.2. So what they said is that the sandstone bed dipping, sandstone bed in a dam side dipping at 1:4 due south 24 degrees west. So this is your true dip direction and as well as amount. So this is the true dip direction, this is the true dip amount. Find the direction of apparent dip. They are asking us to find out the direction of apparent dip when apparent dip amount is given, that is 1:5.5. So first let us write down the given data. So what they say that we have apparent dip direction as south 54 degrees west and amount as 1:4. Strike direction as usual you need to find out. They have given apparent dip amount, that is 1:5.5, and we need to find out the direction of it. Okay, so with this we'll start plotting it. First we'll plot north south east west line. Okay, so your north south east west line is this. Then okay, I am plotting it a bit on the topper side because we have south 54 west. Okay, so this is my north, this is my south, this is my east, this is my west. Okay, and this point I'll name it as point O also. This point I'll name it as point O. Now let us plot the given things. So they said south 54 west, it will come in this direction. South 54 west will come in this direction. So the 54 will be, this is 45 almost, and 54 will be probably in this direction. This is 54. Okay, I'll write down here. This is true dip. This is, I'll write down. This is my true dip. South 54 west. Okay, and amount is how much? 1:4. So I'll measure 4 centimeter here. I'll name that point as point A. Okay, and then I'll plot a perpendicular to this line. I'll plot a perpendicular. The probable perpendicular will be of this kind. Okay, not maybe exact, but let's see. Again, once again I'll do it. I'll try it once again. Yes, somewhat correct. I'll try once again. I'll probably try it properly only. Okay, so almost it's correct. This will make a 90-degree angle here, and similarly I'll transfer the line here also. Parallelly I'll be transferring the line here also. Now, so the given data whatever was there, that is the true dip direction and true dip amount we completed. Now remind this amount is, we have apparent dip amount. So what I'll do, I'll take protractor, I'll measure, I'll take protractor, I'll measure 5.5 in this. Okay, and with that I'll cut on the both the sides. I'll cut on the both the sides. So probable, I'm just predicting it. Okay, so here it will cut, and this side somewhere here it will cut. Okay, so these points, wherever it is intersecting, these points I'll name them as point B and point C. Point B and C. Then what I'll do, I'll join these two points. I will join these points. To the point O, to join it at to the point O. Okay, join it to the point O. So if you measure the distance, OB, measure the distance OB, and if you measure the distance OC, okay, this will be 5.5. and if you measure these angles, if it is on the north side it will be like this, and this will be like this. If you measure the angle, this I will change to yellow. If you measure these angles, you will get the something called as the strike dip direction. You will get something called as strike dip direction. Okay, so this completes. Then this is your strike lines. These are your strike lines. So measure this angle and measure this angle. Again I will say dark red, maroon color. This angle and this angle you measure, you will get strike direction. You will get strike direction also. Okay, so this is how you need to complete this problem. You solve this and give me the answer for it. Okay, let's see problem number 3.3. So here there are few twists which they have done it. Okay, let's see what they have done. In a road cutting, a banded hematite quartzite BHQ is one of the iron bearing rock. Okay, has a true dip of 1:6.5 in north 25 degrees east. The same BHQ has an apparent dip of 1:7.5 and 1:9. So they have given two apparent dips. Earlier they were giving only one apparent dip. Here they are given two apparent dip, and we need to determine the apparent dip direction. Okay, and same way the strike direction. Okay, let's write down the given data. So they have given true dip direction. They are given true dip direction, that is north 25 degrees east. Sorry, I written it in amount. They are given direction as north 25 degrees east, and they give amount as 1:6.5. In case of apparent dip amount, they are given two amounts. So this one is to 7.5. So 7.5 and another is 1:9. So they are given two apparent dip amounts. So totally there will be two directions for this and two directions for this will come. Okay, let's see how to solve this problem. Okay, how to solve this problem also. North 25 east it is, right? First let me write down, this is my north, south, east and west, and the center point as point O. Okay, now I need to plot north 25 east. So north 25 east will come in this quadrant. North 25 means something of this kind. It will be originating from the point O and originating on point O. Okay, so this is my north 25 east, amount is 1:6.5. 6.5, say I'll say it here, mark it here. This is my 6.5 and I'll name that point as A. Now I need to plot, like previous, I need to plot the true dip direction here. Okay, so I'll do one thing. I'll reduce quickly. I'll reduce it. North 25 east 1:6.5. So I will take 6.5 here only. 6.5 here I'll name that point as point A. Now I need to plot a perpendicular line to that. I need to plot the perpendicular line to that. So probably bit of this kind. This will be the perpendicular line to the straight line. Okay, this is 90 degrees. Okay, so this is 90 degrees. Parallelly, I'll transfer this line over here also. Parallelly, I'll transfer this line here also. Okay, this is my straight line. I'll denote it as SL, straight line. Now, what you need to do is take a compass, measure 1.7.5 or this measure 7.5. Okay, then with the 7.5 mark this and this you may mark. Okay, now again join these parts. Join this as well as this and name them as B and C. Name them as B and C. If you take a direction, I will change color. If you take this direction and this direction, I'll change to blue. If you take this direction and this direction, you will get the direction for 7.5. So if you take direction for 1.7.5, what will be the direction? You will get it from this. Now measure 9 centimeter in your compass. Measure 9 centimeter in your compass and once again do it. Say for I'll extend bit line. Okay, say for you got like this. Then join this also. This should be from O point. Is this joint correctly? Yes, perfect. I'll name this as D and E. If you measure these angles, this and this, okay, then you will get the direction for 1:9. So This is the only difference between these two problems. Okay, like that you have to draw it. Solve this also, you will get the answer for it, and I explain the answer. So set number 4. Here in previous problem they are given us apparent dip, direction, amount and everything here, and we need to find out the strike direction. But what they have done it here, they are given us the strike direction itself. They are given strike direction and apparent dip is given with amount and direction both. They will give with amount and direction. They will give. Okay, and we have to determine the direction and amount of true dip. We have to understand. So the problem number 1, there are only 2 problems, unlike the previous there are no 3, only 2 problems are there. So I'll solve first, remaining second problem you have to solve it by yourself. Okay, so the first problem, a soft shell bed in a hillside cutting is striking, they are given a strike direction that is north 40 west. They are given a strike direction as north 40 west with an apparent dip of 1:5.5 along south 20 west. So the apparent dip direction is south 20 west and apparent dip amount is 1:5.5. Okay, so let's see the given data. So they are given apparent dip direction that is south 20 west. They are given apparent dip amount 1:5.5 and they are given the strike direction as north 40 west. They are given the strike direction as north 40 west. Now what we will do is we'll start plotting the north south east west line. Okay, so this is my north south east west line. Okay, with intersection point, the intersection point as point O. Okay, we are named already. Then now first plot whatever has been given. First start in any problem you need to first plot whatever has been given. So like first I plotted north 40 west. I plotted north 40 west. Okay, this is my strike line. Here is my strike line. Okay, now here we need to understand one part, that strike has always one with respect to north and another with respect to south. So if they say the north 40 west is been given, it is we should understand that there is another line that is north 40 east, sorry, south 40 east also. So we extended this line because in previous problems we have seen this. Now south 40 west is also there. We need, this is understood. If they give south 40 west, we need to understand that north 40 west is also there. Okay, so we extended this line. Then this part is over. This part we completed. Now let us concentrate on the true dip direction and amount. So first south 20 west direction we plotted. Apparent dip direction we plotted south 20 west. Okay, then we'll mark a point. It is 5.5. We mark the 5.5 also, and that point is named as point A. Okay, now we'll shift this line. We'll shift this line at point A. Strike line it is. Earlier we used to plot a strike line here and we used to shift it. Now what we need to do is we have to do it in the reverse fashion. Now this is also over. We are left with the calculation of true dip direction as well as amount. What is the relation here? The true dip direction and amount, they are both the strike line and the true dip, both are perpendicular to each other. So we plotted a perpendicular line from the point O, to the strike line. Okay, so where it intersects this point, intersection point we marked, we named it that point as B, and if you measure, this is perpendicular we plotted, and if you measure this angle, we'll get the true dip direction. And if you measure the distance OB, then we'll get true dip amount. It is as that simple as that. So measure this angle, the distance OB to get the true dip amount, measure this angle to get the true dip direction. It is as simple as this. Once you complete it, this is how the problem will look. in your paper. Okay, so this is how you should look to your paper. Fine.